when the block is at rest, the particles get okay, we'll put a condition like a inelastic collision idea note in the end. Okay, let's get into the concept. So initially, what is the time period? Time period is given by whatever the initial amplitude is given A naught. So what is the initial time period? Time period is given by omega naught K by M. That's all. So after adding mass, tell me what will happen to overall mass of the system. Will become 2m, no? So what do you expect the new time period? The new time period will be omega equal to is it okay? Fine. Omega naught by root 2m. So k by 2m. So k by m is omega naught. The new angular frequency, the time period of oscillations will change. Where do we, what is use of this? You look at the automobiles, we'll be having many moving parts, no? Which will be describing oscillating motion. With the time, what happened? Some dust will get deposited, and the dust, what happened due to grease, will be sticky one. So when it gets deposited on the moving part, the mass of system will increase. If the mass of system increases, time period will change. If the time period will change, then the different parts, if they start taking different time, it was designed for omega naught, now it will become omega. I think there's a big headache. It's a big headache. So therefore, it should be very careful designing will be done. What will happen to the common velocity? It has to change. Vm. So how to calculate this Vm? mv naught into Vm. So Vm equal to V naught by 2. Okay, let's calculate the new amplitude of oscillation. So kinetic energy at 2m by 2 Vm square should be equal to Ka square by 2. Will I agree this? What was earlier? What was V naught? V naught must be equal to A naught omega naught. This was the condition. Okay, let's write here. No, after solving this, Vm is how much? V naught by 2 whole square, K by 2, this is A square. V naught square by 4, K by 2 A square. I'm trying to calculate the new amplitude. That's the only condition. But we don't know any of the things. Okay, you come for like this. What is V naught? You can write it as A naught omega naught square by 4. A naught square equal to, this will become 2. So what is K? You can write M omega naught square. Now look at the conditions. What will happen to amplitude of oscillations? Increases or decreases? I have just wanted, if a system is executing a system at mean position, if mass is added, what is the first case? At mean position, the mass gets added and gets stuck to it. So the time period of oscillation, will it increase or decrease? You have here the discussion. I have placed no. Okay, we'll keep it here. So what will happen to amplitude of time period of oscillation will decrease. What will be amplitude of oscillation will decrease. So what is the conclusion? When a mass is added to system at when it is at mean position, omega, and so both as amplitude and angular frequency decrease. This is a conclusion. If I had the mass at extreme, I can, it's a possibility is there, no? Okay, let's go for the second case. What is the second case? Second case, I'm going to add there's a mean position. Already we know something like, and this is the extreme, no? At extreme point, what is the state of the block? Will be at instantaneous rest. Shall I write IR? I think I cannot write instantaneous, so you have to understand that one. Instantaneous rest it will be. What is the spring force? How much will act? K A naught. Okay, just after adding, so what is the mass of system will become 2m. Anything will happen to the time period of oscillation will change. Okay, time period of oscillations is going to change. Anybody will you say amplitude? Right extreme, left extreme. Anything will happen to the amplitude. So same spring force will not change. So only the new angular frequency will be K by m plus m. So this will be equal to omega naught by root 2. Anybody, amplitude, will it change or remain same? Remain same, no? What was the energy of the system, no? K A naught square by 2, now also K A naught square by 2. So the energy, the amplitude will not change. It's going to be same. That's what I wrote it. A equal to A naught. So on a system, if mass gets added at extreme, amplitude will not change, angular frequency has to change. At mean position, amplitude will decrease, angular frequency will change or will decrease here. Okay, this is about the thing. Okay, now look at the last part. If the mass gets added up at x equal to A naught by 2, this will be very interesting for you, will really help you a lot. Okay, let's construct the diagram. I'm coming to the third part. Okay, let's have first the basic diagram clearly.